All right, welcome. Let's get started. So Log4j was already part of the keynote this morning, and CJ emphasized that it's important to take the lessons learned from it, and that's what we're gonna do in the next hour with you. So my name is Dennis Kieselhorst. I'm a solutions architect based in Germany. I help enterprise customers with their cloud journey and making the most out of AWS services. And besides that, I'm also interested in open source. I'm a committer at Apache Software Foundation, not in the Log4j project that this talk is about, but in other projects, and they all use common mechanisms. And I do the talk together with Marshall.
Yeah. Welcome, everybody. My name is Marshall Jones. I'm a security specialist solutions architect here at AWS. Been here roughly 3 years in a couple of different roles in professional services and now security architecture, where I help customers adopt AWS security services. So how do you scale them? How do you operationalize them? And kind of doing that day to day, working with different customers. So hand it back to Dennis.
All right. So what are we going to cover today? So we'll start with a zero-day overview for those of you who have never heard of zero-day as a term. Then we'll get into Log4j. So what happened end of last year? What is Log4j at all? And how did the issue work? Afterwards, we'll take a look at 2 other zero days to identify some common themes that all those zero days have in common. And we move on to the cybersecurity framework of the National Institutes of Standard and Technology, just to align the priority for the proactive measure that you can take away for the next upcoming zero day. And we'll end up with some quick wins and long-term strategies. So what is a zero day? I brought a definition out of Wikipedia, but before we start with what a zero day is, let's revisit what's the typical way how you should deal with security bugs. So if you come across a security bug in a particular software product or even in one of our services, what you should do is get in touch with the vendor and report it directly on a private channel. And that way you can avoid zero days. At AWS, we offer a dedicated website where you can get in touch with us, with our security teams, and discuss those kind of potential issues. Even if you are unsure, you can just reach out and discuss it with us without disclosing it in the public. And the same is for Apache Software Foundation. They also have a process in place where you can reach out to the central security team. They will then take the issue to the individual project team that's maintaining the open source project, and they may release a patch, get back to you, and then document it and release it before the issue gets disclosed. A zero day, on the other hand, is if you are not following that and instead just raising a Twitter post, for example, and talk about it and disclose it to the public without involving the vendor upfront. And this makes it difficult because then the vendor is surprised as well and needs additional time to figure it out and release a patch. And that way, we have a zero day in place. What happened with Log4j? So Log4j, first of all, for those of you who are not deep into open source and Java as a development framework or programming language, Log4j is a de facto standard logging framework in Java. Although in the Java development kit, JDK, there's an integrated mechanism that you can leverage for logging as well. In the past, it wasn't that powerful. It had a lack of features, and that's why most developers just pulled in another library to do the logging. And Log4j is one of those libraries in place for many years. This is therefore integrated into many applications. And the vulnerability, so the bug in Log4j works like that. So we have a user outside and we have an application deployed on a server. And the first step is that this user just requests something. So the server is open to the outside world in the internet and accessible, and the user puts the requests and directs it to the server. And inside this request, there's a special header value. So the user figures out what is the value that's likely going to be logged on the server. And in this case, the user agent looks like a good candidate because people oftentimes want to figure out what user agents are accessing the particular website and then build statistics out of it later on. And you see the value here. It says JNDI, LDAP, and it's in bracket and with a dollar sign. So JNDI stands for Java Naming and Directory Interface, and JNDI as a functionality to look up values from somewhere else. So what's done here now is this value is taken into the Log4j implementation. So the string itself is passed to the Log4j implementation, and then it gets interpreted. So due to the dollar sign and the brackets, Log4j thinks, okay, I need to resolve this. So it contacts the LDAP server outside. And this is an LDAP server that's just followed by the URL, so the host name given there. And then it resolves something from the outside LDAP server. And this can be a static value, but it can be also a Java class. So Java classes can be serialized and deserialized. And in this case, there's a Java class stored on the LDAP server. And this one gets transferred back to this server here. And as soon as this is on the server, it gets deserialized and initialized. And you may wonder, hey, do I need to call this class or instantiate it? No, you don't need to do it, because as soon as it's loaded, the static constructor given there gets executed. And by putting code into this static block, you can trigger remote code execution if you follow this whole cycle. So this is what the vulnerability is about. Another thing where you don't need to even go through the full cycle is if you think about DNS lookups. So imagine you have some environment variables on your server, like you are not following the role-based approach to access AWS services. Instead, you have put in the AWS access key and secret into environment variables. It would be possible to resolve those variables as well by just putting the environment variables into dollar brackets. And then you just do a DNS lookup. And by doing the lookup, the values get transferred to the DNS server, and you can just pull it from the log files of the DNS server as well. So there are some variations of those issues. And those are also listed here. So for any security issue that's been discovered, there is a CVE created. So what's a CVE? A CVE stands for Common Vulnerabilities and Exposures. And it's a catalog where all the security issues that are known are being categorized, and that way we have an overview, and each of the items gets a number. Another thing that comes along with that is a common platform enumeration, CPE. So that's a structured scheme that you can use. It's an XML format for automatically match those kind of issues. So imagine you have your software and you want to find out what potential CVEs are affected. You can use the machine readable structure of a CVE in the CPE format to do that. So if we think of a particular software project that has a descriptor that's often called SBOM nowadays, Software Bill of Materials, if you never come across that. So if you develop in Java, this is something that you can do with Maven or Gradle. So in the end, you get a list of ingredients of your software. You have all the dependencies listed, and then there are tools that can do the matching between those CVEs. and your dependencies in your projects. And then there are 2 scores given as well. There's a common vulnerability scoring system, which goes from 0 to 10. And you see the first item, so the issue I just explained to you, it has 10.0. So this one is pretty critical. And then there's the exploit prediction scoring system. So this is a probability value. And you see it's 95% as well. So pretty high. So why don't we have just a single entry for the log4j issue? So it was like that. People started patching, looking into it, rolling out the first fixes. Then more people did testing, verification, and afterwards they noticed the fix was incomplete and there were even more issues inside it. So we ended up with 4 issues for that particular log4j thing, and many customers had to really patch several times. So, and that's why this was, even before Christmas, a really time-consuming thing for many people. So immediate reactions. So what did our customers say? And they reached out to me, to my SA colleagues, to Marshall and the specialists, also to our support organization, and asked us, hey, AWS, can you help us? How do I figure out if this is in my environment? So I'm not sure. There are many applications running. We haven't touched them for years. They are just running. The experts are not approachable right now. Maybe even third-party tools are in there. So how do we figure out if we are affected at all? And Marshall will show you later on some tools that we are offering that can help with that. Another question was, is AWS using Log4j? And which version? Please tell us. And the answer was, yes, we are using a lot of Java in our services, and Amazon as a whole company is using a lot of Java. And we were also using the version that was affected by the bug. And of course, the next question was, customers asked us, hey, what are the services that are affected and what's the status of the patching? And what we did is we published a security bulletin. So it was publicly, or it is still publicly readable on our website. And we updated it frequently to keep you updated on the progress. We listed service by service, what the status of the patching is and what service is affected and what not, to keep you updated transparently. Next question was, how do I protect my environment? So there, as you saw, there were 4 issues, and sometimes it took a while until the patch was released by the open source community, although people were working pretty fast on it. And there was a particular interest to protect the environment, although there's no patch available yet. And we'll see, again, some services later on that help with that. And this is also a learning you can take away for the next 0 day, something you can put into your playbook as an incident response if there's no patch available. Remediation was also a critical part for many customers because it is a standard component. So it's not just one application that you just take and then you patch it and you roll it out. As logging is a standard thing, it affects many applications, and customers had to patch it across their whole IT landscape. So they were particularly interested in how can I automate that. We will cover this today as well. And the last thing, should I get rid of open source software? So for me as an open source fan, it was really painful to see that customers are no longer trusting open source. And the answer is no, you should not. In the end, open source still offers transparency, and the people really collaborated to get the project more secure in the end. And open source is, of course, still a great thing. So along with those reactions, it was important for our customers also to understand the shared responsibility model. And you may have seen that in other talks today as well. But it's still important just to refresh it. What you see here is the version of this shared responsibility model that deals with managed services. Managed services means AWS Lambda, for example. So a service that we offer to run serverless functions. And in this case, you are responsible for the function code that you are running on Lambda, but you are not responsible for the operating system and for other aspects that we offer as part of the service, because we manage it for you. But still, you can package a particular Log4j library with your function code. And if you do something like that, it's your responsibility to also patch this library that you bundle with your function code. Whereas if the logging functionality is inside the service itself, so it's used to work with logging inside the service, then of course we take care of the patching for you. And that's why it's always important to see service by service what is your responsibility and what is the responsibility of AWS. So common themes. Let's take a look at 2 more 0 days just to compare what those have in common with the Log4j issue we've discussed. And I just selected 2 0 days that also happened this year. The first one is Confluence. So Confluence is a really great wiki software. I used to work with it a lot in the past. And what happened with Confluence is that there was an insufficient input validation where you could put object graph navigation language expressions into the request. And that way, it allowed you to run code on the server where the wiki software is hosted. And another thing is Spring for Shell. So Spring is a famous Java development framework for enterprise applications. So there was Java Enterprise in the past part of the standard, and then Spring came to simplify all of that, and that's why many Java developers are still using Spring. And there this year, it also happened that there was an issue related to data binding. So it was possible to put query parameters or form data and trigger remote execution via data binding. And if we take a look at those two and the Log4j issue that you've just seen, what did these have in common? So it's always crafted traffic that cause the system to respond with some sensitive data. So you craft a special request, you send it to the server, and then sensitive data gets sent somewhere else or responded directly. And actors can use these openings to gather credentials, or they just run remote code. And they can also do persistent stuff on the servers, like create something that you don't want to. And the last challenge I already covered is, as we are talking about standard components, so not narrowed down to one particular application, there's a challenge that you need to patch your whole IT landscape, and you have a lag in patching, and that's something that, oftentimes those 0 days in standard components have in common as well. So what can you do against that? So there are the OWASP top 10. So OWASP is the Open Web Application Security Project, and they are releasing a top 10 list every few years. So this ranking gets updated regularly as well. And what you see inside the list is on place number 3, we have injection. So injection is covered there. And if you see it for the first time here, I strongly suggest get familiar with the OWASP top 10. It's a standard awareness document. Every developer in your organization should know those most critical security risks and deal with that. So you should really adapt the document and start a process of ensuring you are addressing all those types here to just minimize these risks. So and now, we can think of, okay, is it enough to be prepared for the next 0 day? And no, it's not. And therefore, I'm handing over to Marshall to cover a few more topics and give you some overview about services that help with that.
All right. Yep. Thanks, Dennis. So, like Dennis said, the OWASP Top 10 is great if we're talking about web applications, but if we're thinking about 0 days, this could really be anywhere in the environment. So Log4j is a logging library that happens to be part of a web application, but it could be a part of anything else. So we want to take a more proactive approach that is more holistic across the entire environment, and that's why we want to talk about the NIST cybersecurity framework and then how this helps us drive security priorities across our environment. And another way I like to think about the whole 0 day, right, is this is just potentially the unknown potential risk in a given environment. So, those things are always there. We need to be proactive about some of the things we have in place. So what I'm going to go through is a variety of different services as they align to the NIST pillars, and then how can these things be proactive. I'm also going to give examples about how this could have helped us in our Log4j example, as well as just some common best practices that I think everyone should know about these different services. So if you're not familiar with the NIST cybersecurity framework, NIST is, like Dennis said, the National Institute of Standards and Technology. This is a framework that is provided to help guide security priorities across an environment. If you've never seen this before, it essentially has 5 pillars. So identify, protect, detect, respond, and recover. So we're going to look at each one of these along the way. All right, so the first one is to identify. What does this mean? We need to know what exists in our environment. As security practitioners, how do we know it exists? How do we know what's being deployed? Pretty straightforward. So the first way we should look at this in the environment is infrastructure as code. Is there a standard mechanism for deployment across our organization? Do we know that one app team is deploying infrastructure that's not so far different than the other app team? This can help us if we need to make infrastructure changes quickly in response to some 0 day vulnerability. We know that there's going to be some standard approach to do that across the environment. There's a couple different services that AWS offers for this. So CloudFormation, which most people are familiar with, where you can deploy infrastructure as code with YAML or JSON templates. There's also the Cloud Development Kit, or AWS CDK. So if you haven't used this before, this is a pretty awesome utility. You can deploy infrastructure as code with languages that you might be more familiar with, so Python and Java, .NET, TypeScript, and some others as well. The next service I want to talk about is AWS Config. So Config essentially can look at the resource configurations of all of your different AWS resources in your environment. So think about if a security group adds ingress rules. You now see that, before this security group had this X configuration, it's been changed. Now it has Y configuration, and you can track what are these different resources configured in your environment, and then you can deploy AWS config rules that can essentially evaluate, well, if a resource gets changed to some configuration, we maybe now see this as a misconfiguration in our environment. We can identify these things and reduce the risk of different AWS resource configurations. I guess I can't hit these buttons. So the next service is AWS Security Hub. Security Hub has a couple different functionalities, but one of the main functionalities of Security Hub is acting as that cloud security posture management solution. So there's different security standards. There's CIS. There's also the AWS Foundational Security Best Practices standard, and it's essentially a curated list of security checks that AWS has put together to say, look, this is what we see as what we think security configuration should be in an environment, and let you go assess your environment to evaluate against these configurations. So it can give you a lot of visibility into what might be misconfigured across an entire organization. So now that we have identified some stuff, we understand how applications and infrastructure is deployed, we know how we're going to assess those AWS resource configurations in our environment. Now we need to potentially protect those AWS resources. So we'll jump into some things that we can do there. And the first, which should not be overlooked, right, is identity and access management. In AWS, you have to give permissions to make API calls against an environment. So we definitely need to be adhering to least privilege to understand we're not giving overly permissive roles to IAM principals that shouldn't have access to that, once again, reducing risk in an environment. Service control policies, if you're not using them, can be very powerful. So there's some common scenarios after some sort of zero-day or security issue in an environment. Somebody might try and turn off logging so that they're covering their tracks, or might try and turn off some detection services so that anything that they're doing isn't detected. These things can be controlled with SCPs across an entire organization. There's probably only a couple principals that really need to have access to do these types of activities. So we should be locking down who can actually do this in the environment. We can do that with service control policies. Next is the AWS Web Application Firewall. So AWS WAF is a managed web application firewall. AWS is handling the scaling of the infrastructure behind the scenes. You can get started pretty quickly with AWS managed rules. You can write your own custom rules. There's even third-party rules. So if you're familiar with other WAF providers out there, it's likely that they have rules that you can subscribe to in the AWS marketplace. In the specific example for Log4j, there is a rule called the known bad inputs rule, and that was being continually updated with a rule specific for Log4j to block those JD&I lookups that Dennis was talking about earlier in that scenario. Also, a common scenario that we saw was scanning traffic from anonymizers, right? So think about those Tor exit nodes. There's also another rule group that's called the anonymous IP rule group that would have been blocking these type of Tor exit nodes, scanning your environments, looking for those vulnerable applications that have Log4j on them. So we could have stopped that, proactively without ever knowing, what Log4j really was if we were using some of these common rules. There's a couple others that I certainly want to call out. So another AWS managed rule is the AWS WAF core rule set. This focuses on the OWASP top 10 and those specific attacks that are specifically there. So if not familiar with that, it's a very robust rule and a great one to get started with. Another one is the capability to do geo-blocking. A lot of companies don't do business with every single country in the world, so you maybe shouldn't be allowing access to every single country in the world, right? And with some pretty basic geo-blocking rules, you can put some stuff in place to stop that type of activity really before it ever starts to your application. So the next two services that I'm going to talk about are really focused on egress filtering or egress security. A lot of customers I talk to aren't doing anything for egress security currently, and it's I feel like a very missed opportunity. There's some simple things that you can do to add a lot of value to your environment through egress filtering. So think about the example of command and control softwares like Cobalt Strike or Metasploit. These need outbound communication to work. So if you had some pretty basic egress filtering rules in place, you could stop that stuff from ever happening, whether you knew it was in your environment or not. So the first service is the Amazon Route 53 Resolver DNS Firewall. Once again, another managed AWS firewall that gives you the capability to either do deny listing. So say, for example, you don't want to allow resolution to every FQDN for every top level country code, probably not something that's required for every application out there. So we could block certain top level country codes. You can also be more stringent and do like an allow listing. So say, for example, you only need to resolve to the .com domain. You could only allow the .com domain resolution and then really be more strict in the environment. In the example of Log4j, once again, another probing kind of pattern that was happening out there was using DNS canary tokens to understand where this Log4j vulnerability still existed in what applications. With the Route 53 Resolver DNS firewall, you would have been able to block this type of activity, whether you knew about Log4j beforehand or not. So the next is AWS Network Firewall. So a managed layer 7 capable network firewall, which now actually can handle traffic up to 100 gigs. You can use Suricata compatible IDS, IPS rules to block inbound as well as outbound traffic in the environment. This could have stopped or prevented the use, like in Log4j, where LDAP was using non-standard ports. So LDAP over port 53 and 80 and 443, not really anything that is a common scenario for the majority of environments out there. So not something that we should have, we should be letting by default. So we could stop that type of activity with a network firewall and some of these rules. Another common scenario is blocking port 53. So using that .2 resolver, the VPC resolver that's native to AWS, there's going to be a couple of advantages to this. One of those advantages is you're forcing inspection through that Route 53 resolver firewall that we just talked about a minute ago, potentially blocking or forcing inspection for that. And then it's going to make sure that GuardDuty has the visibility to inspect those logs. So GuardDuty looks at those DNS resolver logs that are collected through that built-in VPC resolver, the .2. This is going to ensure that it's forcing traffic through there and it's able to have the visibility there. So we've talked about identifying the infrastructure, identifying resource configurations. We know about some of the different services that can help protect. One thing I should point out is this certainly isn't an end-all be-all, right? There's other things out there. There's lots of open source tools and other AWS services, frankly, that can help, but we wanted to point out some of the main ones. We also know that you can't possibly protect against absolutely everything, right? That's maybe not realistic. If we had a crystal ball, we wouldn't be up here. So we need to also think about how we're going to detect different potential malicious activity in our environment going forward. So first off in detection is Amazon GuardDuty. If you're not using GuardDuty, it is a pretty easy to set up service that begins collecting a number of different logs in your AWS environment, looking for malicious or suspicious activity from a bunch of different places. The rules behind this are always getting updated. The GuardDuty team is continuing to update them. In the example of Log4j, they were updating to build in specific details, part of different findings that would indicate whether it was associated with the Log4j vulnerability. If you watched the keynote this morning, this was highlighted. This was a big deal, right? The new Amazon GuardDuty malware protection was announced. This is an agentless malware scanning feature that's part of GuardDuty. This can really give a lot more context to security professionals, right? So maybe we have some sort of command and control type of finding from GuardDuty, but we can also now see the individual malware, that where is it on the host, what's causing that outbound activity that's connecting out to that command and control domain. We really can tie all the pieces together and help with our investigation and kind of a root cause and getting rid of that activity that's bad in our environment. So GuardDuty can detect suspicious, malicious activity in the environment. Inspector is there for looking for vulnerabilities in our EC2 instances, as well as the container images in ECR. One thing about Inspector, if you're not too familiar with, it is a continuous vulnerability scanning service. So that means if you're installing new packages, if there's new CVEs being published, it's continually looking for if that is present in a given environment. It's not a point in time scan of old, right? It's not once a week, once a month, and hopefully certainly not anywhere past that. For detection, it's really important to have logging turned on before the activity starts. So this is going to give us that historical data into what might be going on in our environment, whether that's at the control plane or the data plane, and let us build that historical record of what's going on. So there's different AWS logging like CloudTrail that gives us all the API calls in our environment. There's VPC flow logs that shows us that network traffic in our VPCs. We can use CloudWatch to collect host-based logs. So those application logs, we can collect that and query that with CloudWatch. So it even gives us the capability to see that at the OS level as well. But certainly important to have this in place beforehand and not scrambling to do this or have these enabled or figure out how to query them afterwards. And then another service that a lot of people I talk to are not too familiar with is Amazon Code Guru. So this can help out with operational code efficiency and making those better from an operational perspective, but it can also help out with finding vulnerabilities in custom-built code in an environment. So these might be vulnerabilities you're introducing in your own custom applications. This can help you find some of that kind of bad coding practices that might lead to a security issue. So we've looked at identifying, protecting, detecting. If something is detected, we got to know how to respond to this. The one service that can really help us with the response piece is AWS Systems Manager. AWS Systems Manager has a lot of different functionality and a lot of different features, like Patch Manager that's going to help with the patching in response to some sort of zero-day vulnerability and a patch being released. This can be set up on schedules. It can be set to, at a certain criticality, automatically take those patching actions. It has a lot of flexibility. There's also the ability to do Systems Manager run commands. So across a fleet of EC2 instances, if you need to go run some bash command to understand what is on the actual OS of those, across a fleet of instances, right? You can go use these Systems Manager run commands to do that type of activity, like answering the question from earlier, does Log4j exist anywhere in our environment? A lot of times as a security team, you don't know or have total control over what your application teams are deploying. So maybe you need to go find out where these jar files exist in a given environment. Another really, really, really important thing that I can't stress enough is playbooks and runbooks. So playbooks being the instructions to how something happens, and then or like how an investigation might happen, and then runbooks maybe more of the technical piece to what do we do once we have our decision made. These are vitally important. It can help make sure that everyone from the junior resources to the principal resources understand every step along the way in your environment. And especially for folks, we don't do this every day. We're not looking at zero-day vulnerabilities or responding to big security issues on a daily basis. Most of us, we do other things. If you're not staying familiar with it, you might not know every step along the way. So I wrote some of my own personal tenets. If you don't have any, just go ahead and dive in. It's really not as bad as you might think. And just get started in every different piece of your environment. Practicing is incredibly important. You could write it once. I write things all the time and I don't look at them for a month and then I forget what I wrote. So you got to keep practicing. And then don't skip parts. Really no part is too small. For example, you might only be thinking about the technical pieces when we're talking about playbooks, but you got to remember, like, if somebody gets stuck in a certain section, well, who's the owner of that section? How do they contact them if it's 2 a.m.? Or who's the escalation from that point? You got to understand these different things, and they need to be built out in your playbooks. And then continue to iterate. People are always leaving. People are always coming. Technology is always changing. That needs to be part of the change management process in an environment, that these playbooks be kept up to date, the contacts be kept up to date all the way across the way. And then the last piece, the last pillar of the NIST framework that we're talking about is the recover stage. So most people fundamentally kind of understand the recover stage, right? How do we get back to where we were before? A lot of people have heard about recovery time objective and recovery point objective. These are normally common things that we talk about it's important to understand them, important to understand what's the criticality of an application and how much time and resources do you spend into what you need to do from a recovery standpoint. I really only want to highlight one service here. AWS Backup can help with doing these backups at scale and backing up different applications, as well as the data protection components of any backup process, right? So that's obviously important if you're storing a bunch of data. How do you handle that data protection at scale in these backups as well? And AWS Backup can help with that. So how does some of this apply to Log4j, the example that Dennis went through earlier? I've given some examples along the way about what are some of these things that could have helped with, but we'll look back directly at our scenario from earlier and talk through how this could have helped. So first of all, blocking these JD&I lookups with WAF. We talked about the known bad rules input, or known bad input rule that's built into, it's an AWS WAF managed rule. This could have helped blocking those JD&I lookups before. We could have potentially patched Log4j with Systems Manager Patch Manager. We could have also potentially disabled Log4j using Systems Manager run commands across our fleet of EC2 instances. We could have disabled the JD&I lookups ability within our application. So also another thing is we could have had basic egress filtering put in place that would stop those kind of that outbound traffic from being successful. And then finally, we could have disabled remote code bases using that JVM systems property, and that could be done either whether it's from infrastructure as code or through, once again, that systems manager run command. So finally, we want to make sure that we didn't just come up here and talk about a bunch of services and Log4j. A lot of people have read a lot about this, but if there's some tangible things that you can leave here and go, are we doing this in our environment? Is this something that we need to look into? We wanted to have some quick wins, things we think are relatively easy, can be implemented quickly, can be adopted quickly, but then also talk about just some long-term strategies that people need to continue to think about. So first is implement basic egress controls. So that's the DNS firewall as well as network firewall has managed rules. These are some things that can be implemented without too much heavy lifting on your behalf. Implement guard duty across your organization. So it can be turned on with a few clicks. You can use AWS organizations and deploy this out, whether that's hundreds or thousands of accounts, relatively easy. Use those managed WAF rules, whether that is that core rule set or some of the more specific rule sets. There's some that are specific to Windows or Linux-based applications, but look into those managed rules, understand what they do, and then implement the ones that are best in your environment. Button malfunction again. And then something really basic that might be overlooked is NACLs are a free network access control list built into VPC, is a free feature of VPC. There's probably not a reason that you need outbound 1389 port open in your environment. Why? So it can very easily be blocked with something like a NACL, right? If you need to scale this a lot higher, you have things like the network firewall that can help with that. But there is the ability to do some of this basic stuff with NACLs. So for long-term strategies, determine risk across your environment. That's certainly easier said than done. But as security practitioners, time is certainly always stretched. I don't think I talk to any customers who tell me they're overstaffed. So how do you even determine what your priorities are in your environment? Go figure out a way to answer that question, and then you'll know where you need to go spend your time, where you need to go spend your financial resources to understand and secure your environment better. Define your process for fleet-wide patching. You have probably different operating systems, different applications, different teams. How do you know if you had some 0-day that was widespread, again, like Log4j? How do you go patch that? This probably isn't a technical answer either. A lot of these things in the long-term strategies really isn't a technical answer. So how would you do this if you had to do it again? Now's the time to think about it and not later. Identify and enable a quick response team. So this is really who's going to own the process across all parts of the organization. So your security org, maybe it's this application team ownership, maybe somebody from legal needs to be involved. Does somebody on the financial side, are they going to be able to, if there needs to be some sort of financial impact that has to do with maybe bringing in other resources to help, are they going to be able to sign up? How do these things work? Who owns each part of the process? That needs to be identified early and understand who's gonna stand up when you need to do these activities. Get rid of unneeded transitive dependencies. So there is probably a bunch of things installed on your different resources that don't really need to be there. Some people, they do start from clean images. They strip everything out. Most people don't. So removing these unneeded dependencies in your applications, you're essentially reducing the risk in the environment by having less things that could potentially have a 0-day vulnerability. It's also less things that you might be forced to patch later on and spend time on right before Christmas, like with the Log4j example. So develop and test those playbooks. I talked about that a lot a minute ago. That I can't stress that one enough. There are open source playbooks out there that we put out there that you can use to get started. There's lots of resources. And then if I was going to leave you with one thing, it would really be that you need to practice all of these different things and understand these different components. For example, if a professional athlete, right, they don't show up on game day, they're already good or whatever. They spent years practicing, and that's how they make sure on game day that they're locked in. So I mean, as we're being professionals, we should be locked in that same way as well. So practice in a big way. And then with that, I want to say thank you from myself and Dennis. I hope you all got something out of this conversation. We're able to walk away with something, and we'll be here to answer any questions afterwards if anybody has any questions. But if not, thank you.
Yeah, we know we were competing with the drinks, so thanks that so many of you found the way here.